January 15, 1919, the morning arrived in Boston's North End with temperatures that defied the calendar. The thermometer climbed toward 40 degrees Fahrenheit, a reading that belonged to early spring rather than the frozen heart of a New England winter. This was a meteorological anomaly, an unusual convergence of atmospheric conditions that brought unseasonable warmth to a city accustomed to bitter cold during this time of year. The residents of Commercial Street woke to air that felt soft against their skin, absent the typical sting of January wind that normally forced people to hurry from doorway to doorway with their collars pulled high and their hands buried deep in their pockets. The North End was already stirring before dawn broke fully over the harbor. This neighborhood operated on the rhythms of manual labor, where work began early and ended late, where survival depended on the willingness to rise before the sun and spend long hours at whatever employment could be found. The area was home primarily to Italian immigrants, families who had crossed the Atlantic seeking opportunity and found themselves packed into crowded tenement buildings along narrow streets that seemed designed for a smaller, earlier era. These were people who worked at the docks and in the factories, who drove delivery wagons and operated small shops, who scraped together livings from the complex economy of an industrial waterfront neighborhood. The architecture of Commercial Street reflected the haphazard nature of urban development in early 20th century America. Residential buildings stood immediately adjacent to industrial facilities with no buffer zone, no careful planning to separate the places where people lived from the places where dangerous work was conducted. Multi-story tenement houses pressed against warehouse structures. Small shops occupied ground floors beneath apartments where entire families lived in 3 or 4 rooms. The Boston Elevated Railway structure cut through the neighborhood, its metal framework casting geometric shadows across streets that had been laid out centuries earlier when Boston was still a colonial town. This was urban density in its most extreme form. Every available square foot of space utilized for something, whether commercial or residential or industrial. The dominant feature of this particular stretch of Commercial Street was the tank. It had been standing there since 1915, impossible to ignore. A massive cylindrical structure that rose 50 feet into the air and measured 90 feet across its diameter. The tank was painted dark brown, a color that might have been chosen for aesthetic reasons, but which served a more practical purpose that would become clear to anyone who observed it closely over time. The structure belonged to the Purity Distilling Company, which was itself a subsidiary of United States Industrial Alcohol, one of the large corporate entities that had emerged from the consolidation and merger activity that characterized American business in that era. The tank's purpose was storage. Ships arrived regularly at the nearby harbor, carrying molasses from the Caribbean, thick dark liquid produced from sugar cane and transported north to feed America's industrial appetite. The molasses would be pumped from the ships directly into the tank, where it would wait until the distilling company was ready to process it into industrial alcohol. This alcohol served multiple purposes, including the manufacture of munitions during the recently concluded World War, though it also found its way into the production of spirits for human consumption. The tank was a crucial link in this supply chain, a temporary holding facility that allowed the company to maintain steady operations regardless of shipping schedules. The smell was unavoidable. Anyone who spent time on Commercial Street became intimately familiar with the heavy, cloying scent of molasses that permeated the neighborhood. The odor was strongest when fresh shipments arrived and the tank was being filled, but it never entirely disappeared. The sweetness hung in the air constantly, mixing with the salt smell of the harbor and the smoke from coal fires and the various other scents that made up the olfactory landscape of an industrial urban neighborhood. Residents had long since stopped noticing it consciously, the way people become habituated to any constant sensory input. But visitors to the area always commented on it, the overwhelming presence of sugar in the air. On this particular morning, the smell seemed more intense than usual. The unseasonable warmth was drawing the scent out more strongly, making it permeate every surface and infiltrate every building. Women opening their windows to admit the surprisingly mild air found themselves breathing in great draughts of sweetness. Children walking to school noticed it, commented on it to each other. Workers heading toward the docks or the rail yards were enveloped in it. The entire neighborhood seemed saturated with the smell of molasses, as if the air itself had become thickened with sugar. The tank had been filled recently. A shipment had arrived just days earlier, and the great cylindrical structure now held close to its maximum capacity, somewhere in the vicinity of 2,300,000 gallons of molasses, was dense, viscoliquid von water, each gallon weighing approximately 12 pounds. The mathematics of this were staggering when you calculated the total weight the tank's walls were required to support. At full capacity, the structure contained roughly 13,000 tons of molasses, an almost incomprehensible mass of liquid pressing outward against the metal walls that were supposed to contain it. The warmth of the morning was having an effect on this liquid that the tank's designers had either failed to consider or had inadequately accounted for. Molasses, like all liquids, expands when heated. The molecules become more active at higher temperatures, moving faster, occupying more space inside the sealed tank. This expansion had nowhere to go. The liquid was pushing outward against the walls with increasing force as the temperature climbed. The pressure was building, steadily and inexorably, following the basic physical laws that govern the behavior of confined liquids under thermal stress. The residents of Commercial Street went about their morning routines without any awareness of the forces at work inside the great brown cylinder that dominated their neighborhood skyline. Mothers prepared breakfast in cramped kitchens, boiling water for coffee and frying whatever food the family budget allowed. Fathers dressed for work, pulling on the heavy clothes required for outdoor labor even on this unseasonably mild day. Because experience taught that weather in Boston could change quickly and the man caught without his coat would regret it, children ate quickly and gathered their school things, preparing for another day of education in overcrowded classrooms where teachers struggled to manage too many students with too few resources. The physical layout of the neighborhood meant that dozens of buildings stood in immediate proximity to the tank. Directly across the narrow street were tenement houses, multiple families living in each building, their windows looking out on the massive structure that filled their view. The fire station for Engine Company 31 was nearby, a two-story building that housed both firefighters and the horses that pulled their equipment. Because this was still an era when fire response relied heavily on animal power, there were stables in the area where commercial horses were kept, draft animals used for hauling freight and pulling delivery wagons. Small shops occupied ground floor spaces, selling groceries and dry goods and the various necessities of daily life. A public park, if it could be called that, occupied a small plot of land nearby, though it was more of an open space than an actual park. A place where people might sit for a few minutes or children might play when they had time. The Boston Elevated Railway structure was particularly close to the tank. The elevated train line ran through the neighborhood on metal supports, creating a framework of girders and beams that allowed trains to pass above street level. The structure was substantial, built to support the weight of railroad cars full of passengers, engineered to withstand wind and weather and the constant vibration of passing trains. It stood as an example of early 20th century engineering, the kind of infrastructure project that cities like Boston were building to manage the challenges of urban transportation in an age of rapid growth and increasing population density. The morning progressed toward midday. The temperature continued its unusual climb, reaching into the mid-40s. Warmth that would have been pleasant in April but which seemed almost alien in January. People remarked on it to each other. The strange mildness of the day, the way it felt like the seasons had somehow gotten confused. Some welcomed it, grateful for the temporary reprieve from the brutal cold that typically characterized Boston winters. Others found it unsettling, this weather that didn't match the calendar, that violated their expectations of how January was supposed to feel. Inside the tank, pressure continued to mount. The physics of the situation were straightforward. even if the specific numbers would only be calculated later. After everything had happened, the molasses was warming, expanding, pushing outward with increasing force. The metal walls were being subjected to stress levels that increased with each degree of temperature rise. The structure was being tested, its design and construction being challenged by conditions that may or may not have been anticipated by the people who had built it. The tank was making sounds. It had been making sounds for quite some time, actually low groaning noises that suggested stress. That spoke of metal being pushed toward the limits of its tolerance. Workers at the Purity distilling facility were familiar with these sounds, had been hearing them for months, possibly years. The sounds had become part of the background noise of the workplace, another element in the constant mechanical symphony of an industrial facility. Some workers had expressed concerns about these sounds, had wondered aloud whether they indicated something problematic. But their concerns had not resulted in any significant action. The tank continued to operate, continued to be filled and emptied in the normal course of business. The neighborhood children knew the tank in their own way. It was a landmark in their daily geography, a feature of their environment that they had incorporated into their play and their routines. Many of them knew that the tank leaked. This was not a secret or a hidden fact. The structure wept molasses from its seams, dark sticky liquid that ran down the sides in thin streams. Children would come with sticks or cups to collect this freely available sweetness, scraping it off the metal surface and bringing it home as a treat. In a neighborhood where money was perpetually scarce and luxuries were rare, this free source of sugar was a small gift, something that made the presence of the massive industrial structure seem less like an imposition and more like an unexpected benefit. The adults were aware of the leaking as well. The workers at Purity Distilling dealt with it constantly, mopping up the molasses that pooled around the base of the tank, cleaning the sticky residue from their equipment and their workspace. The leaking had been present from the very beginning, from the first time the tank had been filled. It was a persistent problem, one that the company had never fully addressed despite its obvious implications. A tank that leaked was, by definition, a tank that was not properly sealed, that had seams or joints that were not adequately tight, that might have fundamental structural issues with its design or construction. Commercial Street at midday was crowded in the way that urban working-class neighborhoods were always crowded. This was not a residential area in any quiet, suburban sense. This was a place where people lived and worked in immediate proximity, where the boundaries between different types of activity were blurred or non-existent. Workers on their lunch breaks stood in clusters, eating whatever food they had brought from home or purchased from street vendors. Women ran errands, visiting shops to purchase the day's groceries, carrying everything home because refrigeration was either absent or limited. Children were present in substantial numbers, some legitimately released from school for the midday meal, others simply absent from school for reasons that ranged from illness to economic necessity to simple truancy. The horses were everywhere. This was still very much an age of animal power. Automobiles existed, certain, but that yet displaced the horse-drawn vehicle as the primary means of urban transportation for goods and materials. Delivery wagons pulled by horses moved through the streets constantly. The fire department still relied on horses to pull their engines and equipment. Commercial stables housed dozens of animals. The presence of so many horses was simply a fact of urban life, accepted without much thought by people who had grown up in an era when this was normal. The fire station was particularly busy on this shift. Engine Company 31 was staffed by professional firefighters, men who had made responding to fires their career in an age when urban fires were a constant threat. The station housed the men, the equipment, and the horses all under one roof. Firefighters maintained their gear, trained, waited for the alarm that would send them rushing toward whatever building was currently burning. The horses stood in their stalls, ready to be harnessed at a moment's notice. The entire operation was organized around the principle of rapid response. of being able to move from a state of rest to a state of emergency action in the shortest possible time. The elevated railway structure stood silent at this particular moment. No train currently passing through this section of track. The metal framework rose above street level, a geometric lattice of beams and girders, substantial engineering rendered in steel. The structure had been built to exacting standards, designed by engineers who understood the forces involved in supporting railroad cars and the dynamic loads created by moving trains. It was, in its own way, a testament to what careful engineering could accomplish. A structure that performed its function safely and reliably because it had been properly designed and constructed. The clock moved toward 12:40 p.m. The temperature held steady in the mid-40s. Unusually warm air that continued to affect the molasses inside the tank. The pressure had reached levels that the structure had not been designed to withstand, assuming it had been properly designed for any particular pressure level at all. The metal walls were being stressed beyond their capacity to resist. The rivets that held the plates together were being pulled at with forces that exceeded their strength. The entire structure was approaching a critical threshold, a point beyond which the materials could no longer maintain their integrity. No one on Commercial Street understood what was about to happen. They could not have understood, because they lacked the technical knowledge to interpret the signs even if they had been paying close attention to them. The groaning sounds meant something, but what they meant was not obvious to people without engineering training. The leaking indicated a problem, but the severity of that problem was not apparent to casual observation. The unseasonable warmth was pleasant, even welcome, and there was no reason for ordinary residents to connect that warmth with any kind of danger from the tank that had been standing in their neighborhood for years without catastrophic failure. The neighborhood was going about its ordinary business. People were eating lunch, conducting transactions, having conversations, living their lives in all the mundane ways that constitute daily existence. Children were playing. Workers were working. The rhythms of the day were proceeding normally, following the patterns that had been established over months and years of routine. Nothing seemed different. Nothing appeared dangerous. Nothing suggested that within minutes the ordinary afternoon would be shattered by one of the most bizarre and deadly disasters in American urban history. The tank stood there on Commercial Street, 50 feet of metal cylinder holding back millions of gallons of thick liquid, its walls groaning under stresses they could not continue to withstand. It seems weeping molasses as they had been doing since the structure was built. Its entire mass approaching the moment when the accumulated consequences of poor design and inadequate construction and corporate negligence would be paid in full. Part 2. The Corporate Negligence. The story of how the tank came to be standing on Commercial Street and how it came to be standing there in such a dangerous condition is a story of corporate decision-making in an era when regulation was minimal and the consequences of cutting corners could be externalized onto communities that had no voice in the decisions being made. United States Industrial Alcohol was a large corporation, formed through the consolidation of numerous smaller distilling operations into a single entity that could operate with the efficiency and market power that came from size. The company was in the business of producing industrial alcohol, which had numerous commercial applications including the manufacture of explosives and munitions during World War I, which had only recently concluded when the disaster occurred. The decision to build a storage tank in Boston made perfect sense from a business logistics perspective. The molasses that served as the raw material for alcohol production was shipped from the Caribbean, from places like Puerto Rico and Cuba where sugar cane was grown and processed. Boston was a major port with excellent harbor facilities, capable of accommodating the ships that carried this cargo. The Purity Distilling Company, which was the subsidiary of United States Industrial Alcohol that actually operated the facility, had established operations in the North End because it provided the necessary combination of harbor access and industrial infrastructure. Building a large storage tank on site meant that ships could pump their cargo directly into storage. where it would wait until the distilling operation was ready to process it. The tank was designed and built in 1915, right in the middle of the war years when demand for industrial alcohol was at its peak. The urgency of wartime production created pressure to complete construction quickly, to get the facility operational so that it could begin contributing to the supply chain that fed the war effort. The man in charge of the project was Arthur P. Gell, who held the position of treasurer for United States Industrial Alcohol. Gell was not an engineer. His background and training were in business and finance, not in the technical disciplines that would have been relevant to designing and constructing a large industrial structure. This fact is important because it meant that the person making key decisions about the tank lacked the technical expertise to properly evaluate design choices or construction quality. Gell's primary concerns were cost and schedule, getting the tank built as quickly and cheaply as possible so that the company could begin using it and generating return on the investment. The actual design work was contracted to Hammond Iron Works, a company that had experience in metal fabrication and construction. However, the design process appears to have been rushed and inadequate. Proper engineering for a structure of this size would have required detailed calculations of the forces involved, careful selection of materials to withstand those forces, and the incorporation of safety margins to account for unexpected conditions. A cylindrical tank 50 feet tall and 90 feet in diameter, holding liquid as dense as molasses, would experience enormous pressures, particularly at the base where the weight of all the liquid above would be concentrated. The pressure at the bottom of a tank is determined by the height of the liquid and its density. Molasses is significantly denser than water, weighing approximately 12 pounds per gallon compared to water's 8.3 pounds per gallon. When you fill a tank of these dimensions to capacity with molasses, the pressure at the base reaches approximately 15,000 pounds per square foot, or roughly 104 pounds per square inch. These are substantial forces, and the walls need to be thick enough and strong enough to resist them without failing. The design that was actually implemented used steel plates that were, by later analysis, too thin for the application. The calculations that determine the plate thickness appear to have been fundamentally flawed, either underestimating the forces involved or failing to incorporate adequate safety margins. The steel plates varied in thickness, but even the thickest sections were insufficient for the loads they would need to bear. Additionally, there is no evidence that anyone performed proper stress testing of the design, either through mathematical analysis or physical testing, before construction began. The construction process itself was characterized by haste and inadequate quality control. The tank was assembled quickly, with workers under pressure to maintain an aggressive schedule. The riveting that held the steel plates together was sloppy in many places. Rivets are crucial to the structural integrity of this type of construction. Each rivet needs to be properly sized, properly placed, and properly installed to ensure that the joints between plates are strong and tight. Poor riveting creates weak points where the structure can fail under stress, and it also creates gaps where liquid can leak through. The leaking began immediately. From the very first time the tank was filled with molasses, liquid began seeping out through the seams. This was not a minor problem. This was clear evidence that the structure was not properly constructed, that the joints were not adequately sealed, that there were fundamental issues with the way the tank had been put together. A properly constructed tank should not leak. The fact that this one did, and leaked noticeably, should have triggered immediate investigation and remediation. The company's response to the leaking reveals a great deal about their priorities and their attitude towards safety. Rather than shutting down the tank to investigate and fix the structural problems, they chose a different approach. They had the tank painted. Specifically, they had it painted dark brown, a color that would make the molasses leaking down the sides less visible. This was a deliberate act of concealment, an attempt to hide evidence of the structural defects from anyone who might observe the tank and raise questions. The brown paint did not, of course, stop the leaking. It simply made it harder to see. The molasses continued to seep out through the inadequate seams, running down the painted surface in sticky streams that eventually became obvious despite the camouflage. The paint was a cosmetic solution to what was fundamentally a structural problem, and it exemplified the company's approach to safety issues throughout the tank's operational life. The appearance of soundness was considered more important than actual structural integrity. Public relations took precedence over public safety. The leaking continued throughout the tank's years of operation. Workers at the purity distilling facility dealt with it constantly, mopping up molasses from around the base of the structure, cleaning it from equipment and walkways. The amount of molasses that leaked was substantial enough that it became a known feature of the neighborhood. Children came to collect it, as mentioned earlier, treating it as a free source of sweetness. The leaking was so constant and so visible that it became normalized, just another aspect of living near an industrial facility. But some people understood that the leaking was not normal, that it indicated serious problems with the tank's structural integrity. Workers at the facility, particularly those who worked in close proximity to the tank on a daily basis, were aware that something was wrong. They could hear the sounds the tank made, low groaning noises that suggested stress and strain. They could see how much molasses was leaking out and how the leaking seemed to be getting worse over time. They could observe the way the tank's walls seemed to bulge slightly in places, visual evidence of the pressure being exerted from inside. Some of these workers raised concerns with their supervisors. They expressed worry about the safety of the tank, about whether it might fail catastrophically. These concerns were not taken seriously. The workers were reassured that everything was fine, that the tank was safe, that the leaking and the sounds were normal and nothing to worry about. This reassurance came despite the fact that there was no engineering evidence to support it, no actual investigation into whether the tank was safe. The workers were being asked to trust the company's judgment, to believe that the people making decisions about the tank's operation understood the technical issues involved and had determined that continued operation was safe. The reality was that the company did not want to shut down the tank because doing so would be expensive and disruptive. Taking the tank out of service would mean either finding alternative storage for incoming molasses shipments or turning away shipments entirely, both of which would affect operations and profitability. Properly investigating the structural issues would require bringing in engineers and potentially discovering problems that would be expensive to fix. If the investigation revealed that the tank was fundamentally unsafe and needed to be replaced, that would represent a massive capital expense that would be difficult to justify to shareholders and corporate management. So the easier choice was to continue operating the tank despite the warning signs, to minimize the significance of the leaking and the sounds, to reassure worried workers that their concerns were unfounded, and to hope that the structure would continue to hold together. This was a calculated risk, whether or not the company executives explicitly thought of it in those terms. They were gambling that the tank would keep doing its job, that whatever structural deficiencies it had were not severe enough to cause catastrophic failure, that they could continue to defer the difficult and expensive decision of what to do about the clear evidence that the structure was not properly constructed. This calculation involved placing other people at risk. The workers at the facility were being required to work in proximity to a structure that some of them believed was dangerous, with their concerns being dismissed by management. The residents of Commercial Street, who had no say in any of these decisions, were living in immediate proximity to millions of gallons of liquid held back by walls that were inadequately designed and poorly constructed. None of these people had been consulted about whether they were willing to accept the risks that the company was taking with the tank's continued operation. The North End was a working-class immigrant neighborhood, populated largely by Italian families who had limited economic and political power. This was not an accident. Industrial facilities that posed potential dangers were routinely located in poor neighborhoods. because the people who lived there lacked the resources to effectively object. If United States Industrial Alcohol had proposed building a massive molasses storage tank in a wealthy, residential area, there would have been substantial opposition from residents with lawyers and political connections and the ability to make their objections heard. The people of the North End had none of these advantages, and so the tank was built in their neighborhood and operated there despite its obvious problems. The tank had no proper foundation. It sat on a relatively shallow base that was inadequate for the weight it was supposed to support. The ground beneath it was not properly prepared or reinforced. This meant that the entire structure was subject to settling and shifting, which created additional stresses on the walls and joints. A proper engineering analysis would have called for a substantial foundation, carefully designed to distribute the enormous weight of the filled tank across enough area that the ground could support it without excessive settlement. The tank had no proper safety features. There were no pressure relief valves that could vent excess pressure if the molasses inside expanded due to temperature changes. There were no monitoring systems that could alert operators if pressures were approaching dangerous levels. There was no redundancy in the design, no backup systems that could prevent catastrophic failure if the primary containment was compromised. The tank was simply a cylinder of inadequately thick steel, expected to hold back millions of gallons of dense liquid through nothing more than the strength of its walls and rivets. No proper testing had been conducted before the tank was put into service. Standard engineering practice for a structure of this type would have involved filling it with water first, which is much less expensive than molasses and easier to clean up if problems emerged. The water test would have revealed leaking and allowed engineers to assess whether the structure was sound. Any problems discovered during testing could have been fixed before the tank was put into actual operational use, but no such testing was done. The tank was filled with molasses almost immediately after construction was complete, because the company wanted to begin using it as quickly as possible to start generating return on their investment. The documentation of the tank's design and construction was poor. When the disaster eventually occurred and investigators tried to reconstruct what had been built and why, they found that records were incomplete or missing. The specific calculations that had been used to determine plate thickness were not available. The qualifications of the people who had done the design work were unclear. The inspection records from during construction were minimal. This lack of documentation made it difficult to determine exactly what shortcuts had been taken and what specific design or construction flaws had contributed to the failure, though the general pattern of inadequacy was clear. By January of 1919, the tank had been in operation for nearly 4 years. During that time it had been filled and emptied many times, subjected to numerous cycles of loading and unloading. Each cycle stressed the structure, working the metal, fatiguing the rivets, potentially opening the seams a bit more. The leaking had continued throughout, clear evidence that the structure was not maintaining its integrity. The groaning sounds had persisted, audible warnings that the tank was under stress. And no remedial action had been taken, no serious investigation conducted, no engineering analysis performed to determine whether the structure was safe to continue operating. The company had received complaints and expressions of concern from multiple sources over the years. Workers had complained. Some residents of the neighborhood had complained. There had even been some official inquiries from city authorities who had received reports about the leaking and the sounds. All of these complaints and concerns had been dismissed or minimized. The company maintained that the tank was safe, that there was nothing to worry about, that the leaking was minor and the sounds were normal. They provided these reassurances without any apparent engineering basis for them, simply asserting safety rather than demonstrating it. The tank represented a failure of corporate responsibility on multiple levels. It was a failure to properly design a structure for its intended purpose. It was a failure to properly construct the structure according to even minimal quality standards. It was a failure to properly test the structure before putting it into service. It was a failure to respond appropriately when clear evidence of problems emerged. It was a failure to prioritize the safety of workers and neighbors over corporate profits and operational convenience. It was a failure to accept responsibility for the risks that the company's decisions were imposing on other people who had not consented to bear those risks. And now, on January 15, 1919, with unseasonably warm weather creating conditions that placed additional stress on the already inadequate structure, all of these accumulated failures were about to produce their inevitable consequence. The molasses that burst from the ruptured tank did not behave like water. This distinction is crucial to understanding why the disaster was so deadly, why so many people who might have escaped a flood of water found themselves trapped and killed by this different substance. Water is relatively thin, with low viscosity, and when it moves in a wave it tends to flow around obstacles, spreading and dissipating its energy across a wide area. Molasses, particularly in the cool January air despite the day's unusual warmth, was thick and heavy, with viscosity somewhere between 200 and 300 times that of water. This meant that when it moved as a coherent mass, a wall of sticky liquid that struck with enormous force and then clung to everything it touched. The wave that emerged from the collapsed tank was approximately 25 feet high at its initial surge. 2,300,000 gallons of molasses, suddenly released from containment, formed a moving wall of dark liquid that spread outward in all directions but primarily toward the densely populated areas across Commercial Street. The wave moved with shocking speed, estimated at approximately 35 miles per hour in its initial rush, fast enough that people had essentially no time to react, no opportunity to run to safety or take shelter. One moment they were going about their normal activities, and the next moment they were engulfed in a tsunami of syrup. The physics of the wave's movement were determined by several factors. The height from which the molasses fell gave it kinetic energy, converting potential energy into motion. The sheer mass of the liquid, weighing approximately 13,000 tons in total, gave the wave enormous momentum. Once in motion, this mass was difficult to stop or deflect. It crashed through everything in its path with the force of a solid object rather than a liquid, demolishing wooden structures, knocking over brick walls, tearing apart anything that was not massively reinforced. The fire station for Engine Company 31 took the initial impact of the wave. The building was directly across the street from the tank, in the path of the primary surge. The molasses hit the structure with such force that it knocked the building partially off its foundation, collapsing walls and trapping the firefighters and horses inside. The building, which had been constructed to withstand fires and storms and the normal stresses of urban life, simply could not resist the sudden application of thousands of tons of moving liquid striking it at high speed. Walls crumbled. The roof sagged and partially collapsed. Everything inside was instantly coated in thick molasses. The firefighters inside had no warning. They heard the explosion, the sound of the tank rupturing, and then within seconds the wave hit their building. Men who had spent their careers responding to emergencies suddenly found themselves victims of one, trapped in a collapsing structure that was rapidly filling with sticky liquid. The horses in their stalls panicked, screaming in terror as the molasses rose around them, unable to escape their confinement. Some of the firefighters managed to fight their way out of the collapsing building, struggling through the thick liquid that clung to them and made every movement exhausting. Others were trapped inside, pinned by debris or simply unable to move through the molasses that was now several feet deep throughout the structure. The elevated railway structure took a direct hit from the wave. The metal framework, substantial though it was, could not withstand the force of the impact. Support columns were knocked askew, twisted by the pressure of thousands of tons of liquid slamming into them. Girders bent. The entire structure shifted, portions of it collapsing entirely while other sections remained standing but damaged and unstable. The fact that no train was passing through at that exact moment was extraordinarily fortunate. If a train had been on that section of track when the wave hit, the casualties would have been even higher. The wave spread through the neighborhood with terrifying thoroughness. It poured down streets, following the natural slope of the land toward the harbor. It crashed through buildings, smashing through doors and windows and thin walls. It filled basements and ground floor rooms. It caught people in the street, people who were simply going about their business and who suddenly found themselves engulfed in thick liquid that knocked them off their feet and then held them down. The molasses got into people's mouths and noses as they struggled, choking them, preventing them from breathing even if their heads were above the surface. And as the molasses slowly hardened in the winter air, the city's screams were buried inside it. Those who survived were still trapped, every movement pulling them deeper, every second stealing their strength. Bodies weren't recovered in hours, or even days, but weeks. And when the streets were finally cleared, the company gave its answer. It was just an accident. But some people knew that wasn't true. Questions were spreading. Blame was being shifted. And a long, brutal battle was about to begin between money and science, power and truth. Because what happened in Boston wasn't just a disaster. It was a crime. And the verdict on that crime has not been delivered yet. Part 2.